right, the multiplication rule. Now, in order for us to use the multiplication rule, we have to have independent events, okay? Just like for the addition rule, we had to have disjoint. For independent events, we can use the multiplication rule. And the multiplication rule is the probability that both A and B occur. A and, as opposed to or. For addition rule and, we use the multiplication rule. So you can simply just multiply the probability of the two events. Yet again, here's a new symbol. It's similar to this one, okay? These are called set notation symbols. This one means union or. This one means intersection or and. So we call this the intersection symbol, and it means and. Okay, just kind of like that picture down where the A and B is the intersection of those two circles. So the probability of A and B is equal to the probability of A times the probability of B, provided that there is a requirement A and B are independent. You have to be sure that the one event occurring has no effect on the other one in order for you to simply multiply those together. All right, many statistics require us to assume independence. But assuming it doesn't mean that it is true, just because you say I assume it. So it's important that you always think about whether that assumption is reasonable before you actually use the independence rule. So two events, A and B, are not disjoint, provided the two events have probabilities greater than 0. So that's just kind of telling you, if they overlap, if the probability of A and B exists, that means it's greater than 0. Greater than 0. Okay? If the probability of A and B is greater than 0, meaning it can occur. A and B can occur at the same time. So therefore, we could write a statement like this. If probability of A and B, and I could use the symbol instead of the word and. The probability of A and B equals 0, then that tells me that the events are disjoint or mutually exclusive, meaning the two events cannot occur at the same time. Okay? So here them talking about those symbols. You do need to make sure you know those symbols. You need to know this is or, that is and. Sometimes you will see it written as the or. Sometimes you will see it written with the and. Sometimes you will see it using the union and the intersection symbol. So you need to work on making sure you know which one is which. All right, so here's a similar scenario what I was just using as an example a minute ago. Suppose the light at the corner of Highway 115 and the Highway 150 has a 35% chance of being green. So first of all, I like to kind of write that out using symbols. So the probability of green equals, you could write 35%, 0.35, same thing. So that was told to me in the problem. So what's the probability that the light is not green? Not green. And so I can write that like such. That would be not green, green complement. And what we learned, hopefully you remember, is that that just is the complement. 1 minus 0.35, or the two probabilities would add to 100%. And that would be 0.65. Okay? Suppose the probability of yellow is 0.04. So now we've got additional information. The probability of yellow is 0.04. What's the probability that the light will be red? So now we're talking about a sample space here where the only possibilities are green, yellow, or red. And remember, the probability of a sample space is always 1. That's all of your possible events. So now we know green, we know yellow, we want to find red. Okay? These events are disjoint, meaning you can't be green and yellow at the same time, or red, all individual disjoint events. So what I can get from there is the probability of green or yellow or red, that's all of my choices, has to be 1. Well, we just learned from the ORs, when you do ORs, you can add these probabilities together. So the probability of green plus the probability of yellow plus the probability of R because none of them are disjoint, they're all disjoint, you can add them, that has to equal 1. Now you don't have to write all of this out. Some of you kind of already knew how to do this from previous classes, but it's just working through it very step by step. So now what I get is 0.35 plus 0.04, these two numbers were told to me, plus the probability of red equals 1. And now I'm just solving a little equation. These two add to 0.39, subtract that from 1, and I get the probability of red is 61%. And now if you add all those numbers together, 35, 4, and 61, they will add up to 100%, or your sample space. All right, what is the probability the light is red both Monday and Tuesday? So now we want to arrive at the light and it's red, and then we want to arrive at the light again on another day and it is also red. So now this is a compound event, kind of two things occurring. We want it to be red today and red tomorrow. We want both to occur. So as long as we feel the events are independent and that the probability of it being red does not change because it was red one day, we have to assume that. And at this point, I think that's a pretty valid assumption. Assume independence. Then we can find this by just doing probability of red times the probability of red. So in that case, probability of red we just calculated to 0.61. That's 0.61 times 0.61, which is the same thing as 0.61 squared. So I'll go to my calculator, 0.61 squared, 0.3721. Or 37% chance of arriving and it's red both days. What is the probability you don't encounter a red light until Wednesday? So now we're starting off on a Monday, Tuesday, Wednesday, and we want to know what's the probability you don't get a red until Wednesday, which means we want the probability of not red and not red and then red. That's Monday, Tuesday, Wednesday. And these are ands because we want all of this to occur. We don't want a red, we don't want a red, we want a red. Still assuming independence, not red would be these two combined, green and yellow combined, 39%. Multiply by 39% because ands you multiplied. Then multiply by red, 61%. You can type that in your calculator. 0.39, the 0.39 is multiplied by itself, so I'll just hit squared times 0.61. So this is not red, red. 0.092781. And you can start rounding these off. Sometimes we like to go to 4 decimal places when dealing with probability. All right, last one. What is the probability you have to stop at least one red light during the school week? So this is 5 days. Now, this can be really, really challenging when these at least ones. So we want to make sure you really pay attention right here. So what is the probability that you have at least one red? Now, I can't really write that out in this format because there's lots of different ways you could have at least one red. You could have a red on Monday and not any other day of the week. You could have a red on Tuesday and not any other day of the week. Or Wednesday and not any other day of the week, etc., etc., etc. But at least one means you could also have 2 reds. So you could have a red on Monday, Tuesday, or Monday, Wednesday, or Monday, Thursday, or Monday, Friday. Or Tuesday, Wednesday, Tuesday, Thursday, Tuesday, Friday. Or Wednesday, Thursday, you get the picture. You could have 3 reds. You could have 4 reds. You could have 5 reds. So I can't list all of that. I mean, I could, but it would take me a little while. The easiest way for you to do at least one, always, is to do the complement. And you got to start understanding what's the complement of at least one red. So at least one means you have 1, you could have 2, you could have 3, you could have 4, you could have 5. What's the only outcome I didn't list in terms of red? And hopefully you're picking up on the complement of this would be no reds. So remember, you can do the probability of an event by doing 1 minus the probability of its complement. No reds over 5 days. Well, no reds over 5 days is a little bit easier for me to write. That would be no red and no red and no red and no red and no red. That's the only way you could end up with no red, is by having 5 days of no red. So that would just simply be 1 minus no red, which is 39%, multiply by itself 5 times. I can just use an exponent for that, and we get 1 minus 0.39 squared for a probability of 0.8479. So that's a fairly high probability, 85% chance of getting at least one red. I mean, getting a red is already pretty high. So the probability of you getting at least one throughout the week is going to be a pretty high percent.